Welcome. Today we're diving into the world of correlation. Correlation is a statistical concept that measures the relationship between two variables. In simple terms, it tells us whether and how strongly pairs of variables are related. For example, if you notice that as the temperature rises, ice cream sales also increase, you're observing a correlation. But correlation doesn't always mean one thing causes the other. Throughout this video, we'll break down what correlation really means, how to interpret it, and why it matters in data analysis. Let's start by understanding the basics before moving into more detailed examples and common pitfalls. Correlation can be positive, negative, or zero. A positive correlation means that as one variable increases, the other also increases. For example, the more hours you study, the higher your test scores might be. Negative correlation means that as one variable increases, the other decreases. Like the more you exercise, the less you might weigh. Zero correlation means there's no relationship at all. Understanding these types helps you interpret data more accurately and avoid making incorrect assumptions. Next, we'll look at how to spot these different types in real-world data. One of the easiest ways to understand correlation is by visualizing it. Scatter plots are commonly used for this purpose. In a scatter plot, each point represents a pair of values. If the points form a clear upward or downward trend, you're likely looking at a positive or negative correlation. If the points are scattered randomly, there's probably no correlation. Visual tools like these make it much easier to spot relationships in your data at a glance. Let's see how these plots look and what they can tell us. Correlation coefficient is a number between -1 and 1 that quantifies the strength and direction of a relationship between two variables. A value close to 1 means a strong positive correlation, while a value close to -1 means a strong negative correlation. If the coefficient is around 0, there's little to no relationship. This number helps you move beyond just visual impressions and gives you a precise way to measure correlation. Next, we'll discuss how to calculate and interpret this coefficient in practice. Calculate the correlation coefficient. Statisticians often use Pearson's formula. This formula considers the mean and standard deviation of your datasets to determine how closely the variables move together. While the math can seem intimidating, many tools like Excel or statistical software can do the heavy lifting for you. What's important is understanding what the result means and how to use it in your analysis. Let's walk through a simple example to see how this calculation works. Imagine you have data on students' study hours and their grades. If you plot this data and calculate the correlation coefficient, you might find a strong positive correlation. This means that generally students who study more tend to get higher grades. However, remember that this doesn't guarantee every student will follow this trend. There are always exceptions, but overall the relationship is clear. This example helped illustrate how correlation works in everyday scenarios. Let's look at another example. Suppose you collect data on how much people exercise and their weight. You might find a negative correlation, meaning as exercise increases, weight tends to decrease. This doesn't mean exercise is the only factor affecting weight, but it shows a general trend. Examples like this help you see how correlation can reveal patterns in health and lifestyle data, making it a valuable tool for researchers and individuals alike. Sometimes you'll find no relationship between two variables at all. For instance, if you compare shoe size and intelligence, you're likely to find a correlation coefficient close to 0. This means there's no meaningful connection between the two. Recognizing zero correlation is just as important as spotting strong relationships, as it prevents you from making false assumptions based on unrelated data. Common mistake is to confuse correlation with causation. Just because two variables move together doesn't mean one causes the other. For example, ice cream sales and drowning incidents both rise in summer, but buying ice cream doesn't cause drowning. Both are influenced by a third factor, hot weather. Understanding this distinction is crucial for accurate data interpretation and avoiding misleading conclusions. Spurious correlations are relationships that appear meaningful but are actually coincidental. For instance, the number of films Nicolas Cage appears in and the number of swimming pool drownings may show a correlation, but there's no logical connection. These odd coincidences highlight the importance of critical thinking when interpreting data. Always look for underlying reasons before drawing conclusions from correlations. Strength of a correlation is indicated by how close the coefficient is to -1 or 1. Values near these extremes show a strong relationship, while values near 0 indicate a weak or no relationship. For example, a coefficient of 0.8 suggests a strong positive correlation, while 0.2 is weak. Understanding strength helps you decide how much trust to place in the relationship you observe. Direction refers to whether the relationship is positive or negative. A positive direction means both variables move in the same way, while a negative direction means they move in opposite ways. Recognizing direction helps you understand the nature of the relationship and make better predictions based on your data. Weak correlations can still be important, especially in complex systems where many factors interact. A coefficient around 0.3 might not seem impressive, but in fields like social science or medicine, even small relationships can matter. Always consider the context of your data and the potential impact of weak correlations before dismissing them. The size of your data sample affects how reliable your correlation is. Small samples can produce misleading results, while larger samples provide more accurate estimates. Always check the sample size before trusting a correlation and be cautious with conclusions drawn from limited data. Outliers are data points that don't fit the general pattern. They can have a big impact on correlation, sometimes making relationships look stronger or weaker than they really are. Always check for outliers in your data and consider how they might affect your results before drawing conclusions. Not all relationships are linear. Sometimes, variables are related in a curved or more complex way. Standard correlation measures like Pearson's coefficient may not capture these nonlinear relationships. In such cases, other methods or visualizations are needed to understand the connection between variables. When data isn't linear, Spearman's rank correlation can be useful. This method looks at the order of values rather than their exact numbers, making it better for data that doesn't follow a straight line. It's another tool in your kit for understanding complex relationships in data. In the era of big data, finding correlations can help uncover hidden patterns and trends. However, with so much data, it's easy to find relationships that aren't meaningful. Always combine correlation analysis with domain knowledge and critical thinking to avoid being misled by random patterns. Correlation is widely used in finance to understand how different assets move together. For example, investors look at the correlation between stocks and bonds to diversify their portfolios. A negative correlation can help reduce risk while a positive one might increase it. Understanding these relationships is key to smart investing. Medical researchers use correlation to find links between behaviors and health outcomes. For example, they might study the relationship between smoking and lung disease. While correlation can highlight important patterns, it's only the first step. Further research is needed to prove causation and guide medical decisions. In social science, correlation helps researchers understand relationships between variables like education and income, or happiness and social connections. These insights can inform policy and improve society, but always remember that correlation alone doesn't explain why relationships exist. Marketers use correlation to analyze customer behavior, such as the relationship between advertising spend and sales. By spotting these patterns, businesses can make better decisions about where to invest their resources. However, it's important to test assumptions before acting on correlations alone. Educators use correlation to study factors that influence learning, like the link between attendance and academic performance. These findings can help schools design better programs and support students more effectively. But as always, correlation is just one piece of the puzzle. Tech companies use correlation to improve products and user experience. For example, they might analyze the relationship between app usage and customer satisfaction. By understanding these links, they can make data-driven improvements that benefit users. Sports analysts use correlation to find connections between training routines and performance. By identifying what works, coaches can tailor programs to help athletes reach their full potential. Correlation helps turn raw data into actionable insights for better results. Environmental scientists use correlation to study links between pollution and health, or weather patterns and crop yields. These insights can inform policy and help protect our planet. As always, careful interpretation is needed to avoid jumping to conclusions. Businesses use correlation to optimize operations, such as finding relationships between employee satisfaction and productivity. These insights can lead to better management practices and improved results. But remember, correlation is just the starting point for deeper analysis. Psychologists use correlation to explore relationships between behaviors and mental health. For example, they might study the link between sleep and mood. These findings can guide therapy and support, but always require further research to understand underlying causes. We encounter correlation in daily life, from noticing that traffic is heavier on rainy days to observing that people are happier on weekends. Recognizing these patterns helps us make sense of the world and make better decisions, even outside of formal data analysis. While correlation is a powerful tool, it has limitations. It can't prove causation, and it can be influenced by outliers, sample size, and other factors. Always use correlation as one part of a broader analysis and combine it with other methods for the best results. Correlation matrix is a table showing the correlation coefficients between many variables at once. It's a handy way to spot patterns and relationships in large data sets. By scanning the matrix, you can quickly identify which variables are most closely linked and where further analysis might be needed. Heat maps are a visual way to display correlation matrices. Colors represent the strength and direction of relationships, making it easy to spot strong or weak correlations at a glance. Heat maps are especially useful when dealing with lots of variables and complex data sets. Partial correlation measures the relationship between two variables while controlling for the effect of others. This helps you isolate the direct connection and avoid being misled by confounding factors. It's a valuable technique for deeper data analysis. Autocorrelation refers to the correlation of a variable with itself over time. It's common in time series data like stock prices or weather patterns. Recognizing autocorrelation helps you understand trends and make better predictions in fields like finance and meteorology. Correlation and regression are related but different. While correlation measures the strength and direction of a relationship, regression goes further by modeling how one variable predicts another. Both are important tools in data analysis, but they serve different purposes. Negative correlation means that as one variable increases, the other decreases. For example, as the number of hours spent watching TV goes up, physical activity might go down. Recognizing negative correlations helps you understand trade-offs and make informed choices. Positive correlation means both variables move in the same direction. For instance, as income increases, spending often increases too. Recognizing positive correlations helps you spot opportunities and predict outcomes in various fields. In machine learning, correlation helps select features that are most relevant for building predictive models. By identifying which variables are strongly related to the target, you can improve model accuracy and efficiency. However, beware of multicollinearity where variables are too closely related. Manufacturers use correlation to monitor quality, such as the relationship between machine settings and product defects. By understanding these links, they can adjust processes to reduce errors and improve outcomes. Correlation is a key tool in quality management. Customer service teams analyze correlation between response time and customer satisfaction. Faster responses often lead to happier customers. By tracking these relationships, companies can improve service and build stronger customer loyalty. Logistics companies use correlation to optimize delivery routes and schedules. By studying the relationship between traffic patterns and delivery times, they can find ways to improve efficiency and reduce costs. Correlation analysis supports smarter logistics decisions. E-commerce platforms analyze correlation between website visits and sales. By understanding these patterns, businesses can refine marketing strategies and boost conversions. Correlation helps turn online data into actionable business insights. Communication experts study correlation between message clarity and audience understanding. Clearer messages often lead to better comprehension. By analyzing these links, communicators can improve their effectiveness and reach wider audiences. Project managers use correlation to identify factors that influence project success, such as team size and completion time. By understanding these relationships, they can plan more effectively and deliver better results for their organizations. Wrap-up correlation is a valuable tool for understanding relationships in data. It helps you spot patterns, make predictions, and inform decisions across many fields. But remember, correlation doesn't prove causation, and it's important to use it alongside other methods for the best results. By mastering correlation, you'll be better equipped to interpret data and uncover meaningful insights in any area you explore.